In the world of artificial intelligence, large language models are like super smart digital assistants that can understand and generate human-like text. So imagine having a conversation with a computer that can write stories, answer questions, and even translate language as naturally as a human. So these models such as GPT, BERT, and Quinn are built using advanced machine learning techniques and can process and generate text in a way that mimics human language. So in this video, we will dive into the basic concepts and terminologies of large language models, explaining them in the simplest technical terms. So whether you are a tech enthusiast, a student, or just curious about how these models work, this video will help you understand the key components and processes that makes large language models so powerful and versatile. So let's get started with understanding a language model, which is a type of artificial intelligence model that predicts the next word in a sequence of words. It helps in generating text, translating languages, and understanding the context of sentence. Now, large language model is a language model with very large number of parameters, often in billions. It can understand and generate more complex and nuanced text compared to smaller models. Then tokenization, which is the process of breaking down text into smaller units called tokens. Word tokenization, where each word is a token. Subword tokenization, where words are broken into smaller subwords. Say, unhappy might be tokenized as un and happy. Character tokenization, where each character is a token. Next, embedding, which is a numerical representation of a token in a high dimensional space. Embedding captures the semantic and syntactic meaning of tokens, making it easier for the model to understand and process text. Now, context refers to the sequence of tokens that the model uses to make predictions. And this context helps the model understand the surrounding information and generate more accurate and relevant text. Layers are the basic building blocks of neural network in a large language model. So it has different types. First, input layer will process the input embeddings. Hidden layers are the intermediate layers that transform the input, and output layers produce the final output, which is often a probability distribution over the vocabulary. Now, what is vocabulary? Which is a set of all possible tokens that the model can use, and this vocabulary defines the range of words that model can generate. Now, probability distribution is a list of probabilities for each token in the vocabulary. Basically, it helps the model decide on the next token to generate. Now, sampling is the process of selecting the next token based on the probability distribution. It has different methods, where greedy sampling will always pick up the token with highest probability. Top K sampling will pick up from the top K most probable tokens. Nucleus or the top P sampling will pick up from the smallest set of tokens whose cumulative probability exceeds a threshold P. Temperature scaling will adjust the probability distribution to control the randomness. Next comes the temperature, which is a hyperparameter that controls the randomness of sampling process. Higher temperature, say 1, will make the output more random, whereas a lower temperature, say 0.1, makes the output more deterministic. Now, the training is the process of teaching the model using a large data set. Its main purpose is to improve the model's ability to generate accurate and coherent text. Fine-tuning means we are adjusting a pre-trained model on a smaller specific data set, and its purpose is to make the model perform better on specific task or domain. Next comes the context window, which is the maximum length of input text that the model can process at once. Basically, it limits the amount of context that the model can consider, affecting its ability to understand long-term dependencies. Inference is the process of using a trained model to generate predictions or outputs. Its main purpose is to generate text or perform tasks like translation, summarization. Next comes attention mechanism, which is a technique that allows the model to focus on different parts of input when making predictions. It improves the model's ability to understand and generate text by giving more weightage to relevant parts of the input. Next, the transformer architecture, which is a type of neural network architecture that uses self-attention mechanism. It enables the model to handle long-range dependencies and parallelize the training process. Now, overfitting occurs when the model performs well on training data, but poorly on new unseen data. To avoid overfitting, techniques like regularization and dropout are used. Now, underfitting, when the model is too simple to capture the complexity of data. To avoid underfitting, the model architecture training process can be made more complex. Next comes the loss function. So here this loss function is used in the large language models, which is a function that measures the difference between the model's prediction and the actual output. So it helps in guiding the training process by minimizing this difference. Then optimizer is an algorithm that adjusts the model's parameter to minimize the loss function. And there are different types of optimizers like gradient descent, which is a common optimizer that updates the parameter in the direction of steepest descent. ADAM is the adaptive optimizer that adjusts the learning rate for each parameter. Then hyperparameters are the parameters that are set before the training process begins and are not learned from the data. For example, learning rate, batch size, number of layers, and temperature. Now comes the batch size, which is the number of samples processed together in one forward or backward pass. It affects the training speed and memory usage. Learning rate is a step size at which the model's parameters are updated during training. It controls how quickly the model learns from the data. Epoch means one complete pass through the entire training data set. Its main purpose is to measure the progress of the training process. Next comes the validation set, which is a subset of the data used to evaluate the model's performance during training. Its main purpose is to tune hyperparameters and to prevent overfitting. Test set is a subset of the data used to evaluate the final performance of model after training, and its purpose is to assess the model's generalization ability on unseen data. Now, evaluation metrics are the measures used to assess the performance of the model. For example, accuracy, perplexity, blue score, roughest score. These all are the evaluation matrices. Next comes the perplexity, which measures how well the model predicts the next word in a sequence. So, lower perplexity indicates better performance. Now, blue score is a metric used to evaluate the quality of text generated by the model, often used in machine translation. Higher blue score indicates better quality of generated text. Roughest score is a metric used to evaluate the quality of text generated by the model, often used in summarization. So, higher roughest score indicates better quality of generated text. Now, fine-tuning means adjusting a pre-trained model on smaller specific data set. Its purpose is to make the model perform better on specific task or domain. Next, the prompt, which is the initial text or context provided to the model to start generating text. Its purpose is to guide the model's generation process and context. Zero-shot learning means a model's ability to perform a task without any specific training on that task. Its purpose is to evaluate the model's generalization ability. Now, few-shot learning means the model's ability to perform a task with few examples. Its purpose is to evaluate the model's ability to learn from small amount of data. Transfer learning means we are using a pre-trained model on one task to improve performance on different but related tasks. Its purpose is to leverage existing knowledge and reduce the need for large amount of new data. Now, multi-model models are the models that can process and generate multiple types of data such as text and images, and its purpose is to handle tasks that involves multiple types of data like image captioning. Next, ethical considerations, that is the ethical implications of using large language models include bias like privacy and fairness. And it helps in ensuring the responsible and fair use of large language models. Bias means systematic errors in the model's prediction, often happens due to the biased training data. And it basically helps in identifying and mitigating the bias to ensure fair and accurate output. Privacy means the protection of sensitive information and user data. Next comes the fairness, that is the model's ability to treat all users equally and without discrimination, so that the model does not favor certain groups over others. Then explainability is the ability to understand and explain the model's decision so that the model's output are more transparent and trustworthy. And that's a wrap. Large language models are powerful tools that can understand and generate human-like text, making them invaluable in various applications from writing and translation to customer service and beyond. So by breaking down the text into tokens, converting these tokens into numerical embeddings and using multiple layers to process and predict the next word, large language models can create coherent and contextually relevant text. The process of sampling from the probability distribution with techniques like temperature scaling and top case sampling ensures that generated text is both diverse and coherent. So understanding these basic concepts and terminologies helps demystify how these models work and highlight their potential to revolutionize the way we interact with technology. So whether you are a beginner or an expert, the principles of tokenization, embeddings, layers and sampling forms the foundation of large language models. So we hope this video has provided a clear and relatable introduction to the fascinating world of large language models. Thank you.